Here we go on another fun adventure dealing with some exponents in Chapter 6. Today we're going to be looking at rational exponents. And we know that the word rational contains the root word ratio. And we know that ratio indicates we are dealing with a fraction form. So our exponents today will be in the form of a fraction, a over b. For example, the base is the number that we multiplied by itself. The exponent, a over b, is what we have referred to as the power. So this would say b raised to the power of a over little b. Perhaps b was a bad choice. Let's do this. A over c. So let's look into what that rational root indicates. We know this, that the square root of 3, back up again, the square root of 9 is equal to 3. What we're saying is when we take the square root, notice where I placed the 2, we're saying what do we multiply by itself twice in order to get the answer 9. Well, the 3, our solution, would fit into those missing slots. 3 times 3 is 9. We want to look at this in another way. This is called radical form. The little house that we put the big number under is called the radical. The little number inside the radical is called the index. And we're going to take those two numbers and the power of the number inside and use them to write this radical form into rational form. And this is how it looks. The base, 9. The index is the denominator of our exponent, and the power inside is the numerator. So when we say 9 to the 1/2, we are saying take the second root of 9 to the first power. So let's look at example 1. Example 1, part A. It says 125. We are in rational root form. 125 to the 1/3 power. Well, going back to the previous slide, we know that that 3 indicates our index. That 3 is telling us the number of multiplicands we want to have in order to give us the product 125. The 1 is the power of the base underneath. We're saying this, what number times itself 3 times will equal 125. Notice I didn't say any 3 numbers, I said the same number. So in order to do this, we want to think to ourselves, take an easy number, 10 times 10 times 10. 10 times 10 times 10 is 1,000. Way too high. 2 times 2 times 2, 8. Way too low. But the problem is, not the problem, but the issue with these problems is powers grow very quickly. So I want some number in between 2 and 10 that I can work with. 3 times 3 times 3? No, that's going to end in something odd. Well, we have an odd number. 3 times 3 is 9. Times 3 more is 27. Well, we're getting closer. 27. Now, 4 times 4, 16 times 4 is 64. And 5 times 5. 5 times 5 is 25. One more 5 would give us $1.25. 25 times 5 is 125. You can see that we didn't go very high with our numbers. We started with 2 as an estimate. And so we can say 125 to the 1/3 power, or the third root of 125 is 5. Let's go ahead and look at part B. It gets a little more complicated, so obviously we're going to have a little bit more fun. We want 64 to the 1/6. Now I hope immediately you are thinking something multiplied by itself 6 times? That's got to be pretty tiny. So obviously 1 to the 6th is 1, but if we look at 2, 2 times 2 times 2 times 2 times 2 times 2, 2 times 2 is 4, and 3 bunches of those would give us 64. 2 to the 6th power is 64. So our solution, the 6th power of 64, is 2. And we know that we're saying right here, the square root of 25, what times itself is 25. We know that solution to be 5. So our final answer, 7. We've taken the rational exponent and simplified. I want you to check it out, problems 1A and 1B, and they are at the top of page 399. You must show me your solutions in order to get your points for the day. These are your participation points. You get 5 total today. 5 total points. You'll come and show me problems off of this canvas 5 different times to get your points for the day. So check it out, 1A and 1B, and then come right back here for the solutions. So welcome back. Starting out with, check it out, problem 1A. It says 81 to the power of 1/4. That means we are trying to find a value multiplied by itself 4 times. 1, 2, 3, 4. That equals 81. Well, I like to think of it as 9 times 9 and then breaking 9 down. Working backwards that way sometimes helps. So the 4th root of 81 would give us a solution of 3. 3 multiplied by itself 4 times. 1B says we're going to take the 2 roots, the square root of 121 and the 4th root of 256. So writing that out in radical form right here, the square root of 121 is 11. So we take that answer, one of those, and we're going to add it to the 4th root. What do we multiply by itself 4 times? Well, 4 times 4 is 16. 4 times 4 is 16 again, if we can go backwards. We're looking for something that when we multiply it by itself, we get a 6. So a 4 times 4 makes sense, and a 6 times 6 makes sense. So we're going to extract one of those. That is our solution, one single 4. And we add the 11 to the 4 to get 15. Well, it gets a lot more exciting than that, which is a good thing because we wouldn't want to get bored. What if the number is raised to a power that doesn't have a 1? That doesn't have a 1 in the numerator. For example, in your definition, we're looking at b to the m over n power. We're going to think of that in this way. That base again goes under our radical. We're taking the root of b. The n, the lower number, is always our index. What root do we want? How many factors, if you will, of this base do we want? And the power m goes where the power did before. We're going to take one of these and work it out. And I want you to see 2 different ways that we can think of this. Our first one being 8 to the 2/3. Okay? With that example that we just had, we know that 8 is under our radical. We know the denominator is our index, and the 2 is our power underneath. Well, I could think of this as the cube root of 8 times 8, which is 64. Whoops. That's the end of that story. Well, is that as easy as the other option? We could also do this. We could take, this is the same as the cube root of 8. We could take the cube root first and then square it. These are equivalent. This one, in my mind, seems to make more sense because I understand the cube root of 8. 2 times 2 times 2. 2 times 2 times 2. We've completed this part inside. The cube root of 8 is 2, and if I raise that answer from inside now to my second power, I get the solution 4. Over here on the left side, the first one we did, we're asking, we squared first. Over here we squared last. So in squaring first, let's look at this. Now we're saying what times what times what is 64. And we know that to be 4. 4 times 4 times 4 is 64. Again, our solution is 4. 2 different ways to get to it. You need to pick the way that's easiest for you. Let's look at example 2, part A. We want to take 216, the 2/3 power. This is in rational form. Let's write it out in radical form. And I'm going to do this part last. That will be easier for me. So I'm going to think of some number multiplied by itself 3 times. That gives me a solution of 216. 216. Well, I'm going to go higher than 5 because 5 times 5 is 25 times 5 more is 125. I'm going to try 6. I put that in my calculator. Cubing 6 gives me 216. So the inside part, the cube root of 216, is now 6. We've worked the inside of the parentheses, and now I have the outside of the parentheses to deal with. And we get the answer, 6 squared, or 36. So 216 to the 2/3 power is 36. Let's look at part B quickly, and then I'll have you do the check it out problems. We want to look at the problem 32 to the 4/5, meaning we want to take the 5th root of 32 and raise that to the 4th power. Well, I know, because I've memorized this, that 2 to the 5th is 32. So inside my parentheses, the 5th root of 32, I know, is 2. And then I'm going to raise that to the 4th power. 2 times 2 is 4. 2 times 2 is 4. And 4 times 4 is 16. 2, 4, 8, 16. Counting by powers of 2. Go ahead and try, check it out 2A, and check it out 2B, and check it out 2C. You need to show these problems to me. Show me to get your points. Come right back here and we'll go over the solution. So we can see, check it out, 2A, we've taken the 4th root of 16 first, giving us a solution of 2, and then we've cubed 2. 2 times 2 times 2 is 8. 2B, the 5th root of 1, what do I multiply by itself 5 times to get 1? The answer is 1. Any root of 1 is 1. We're going to square that and get 1 again. And 2C, 27 to the 4/3. We're taking the cube root of 27. The cube root of 27 is 3. And then we're raising that to the 4th power, getting a solution of 81. Make sure you show me all the work and those 5 problems so far, 1A, B, 2A, B, and C. And we're ready to go on to example 4.